For our first example, we're going to take that function that we referenced earlier. 25 is equal to 5xy plus 2x squared y squared minus 3x plus 2y. And our objective is to calculate the derivative of y with respect to x. Now let's remember why this is tricky. It's because y is embedded in the equation. Y is embedded in the equation and it's not isolated, so it's tricky to do the derivative as it currently is. So we're going to try an alternative approach, implicit differentiation. So let's pull out our implicit differentiation rules that we derived. dy by dx is what we're going to be looking at, where dy by dx is going to be equal to negative the partial derivative of f with respect to x divided by the partial derivative of f with respect to y. Now we haven't defined what f is yet. F of xy is going to be this whole function. It's going to be the 25, which will be equal to fxy plus 2x squared y squared minus 3x plus 2y. And we can do implicit differentiation because it is consistent with the one condition that we have for implicit differentiation, and that is that the f of xy must be equal to a constant. And indeed, it's a constant 25. So now to determine my dy by dx, I'm going to need the partial derivative of f with respect to x divided by the partial derivative of fy, and all of this I have a negative sign behind. So let's start with our partial derivative fx, which is df by dx, the partial derivative of f with respect to x. I have x's in my f function here, here, and here, and my y's are going to be treated as constants. For the first term, I'm going to have 5 and y being treated as constants or coefficients for x times the derivative of x, which is 1. For the second term, I'm going to have my 2y squared being treated as the coefficient to x squared. Y is treated like a constant. And then the derivative of x squared is going to be 2x. For my third term, it's the derivative of negative 3x, which will be negative 3. And for my fourth term, I have 2y. Y is being treated as a constant, so the derivative of this is 0. Simplifying this, I get 5y plus 4xy squared minus 3. Now let's do our derivative f sub y, which is the partial derivative of f with respect to y. Now my y variables are what I'm doing the derivative with relation to, and my x's are going to be treated as a constant. So for this first term, I'm going to have 5x times the derivative of y, which is 1. For the second term, I'm going to have 2x squared being treated as that constant, that coefficient to y squared, times the derivative of y squared, which is 2y. For my third term, negative 3x, x is being treated as a constant, so that derivative is 0. And for my last term, 2y, the derivative is 2. Simplifying this, I get 5x plus 4x squared y plus 2. Now I can put this all together for my dy by dx expression. I'm going to have negative fx, so negative my fx term right here, 5y plus 4xy squared minus 3 becomes my numerator. And in my denominator, I take my fy term, 5x plus 4x squared y plus 2. And thus I can solve for dy by dx using implicit differentiation.